Let's talk about some of the advantages of using data lakes and good data model structures for continuous improvement. Hello, I'm Tom. Welcome to my channel. We'll talk about continuous improvement in an industrial setting. And today we're going more into the what can we do with bigger data, so to say. Not saying we should immediately go into AI learning, although that is definitely an option for some industries as well. But when we have lots of data, and we do in industry, we have loads of data from our lines, all of our processes, quality, planning, financial reporting. We've got loads of data. We tend to make nice reporting out of them. But those reports, way too often, they're sort of a point-to-point connection. Now, when we can put a good data lake and data model in there, there are some great benefits that I want to discuss with you today. And for that, it is good to realize how we build up our data from basically its source, right? The machine, it can also be manual input, through a model to what we actually display. And this display, that is what most end users will be looking at. It's the only thing that we'll really use. So when, let's say, a reliability engineer builds an OEE dashboard for production operators and supervisors to use, those operators will mainly be looking at a screen, or actually the supervisors will be looking there, the operators will get a double role, but we'll come to that in a bit. That engineer will be setting up a data model, maybe sort of buying this one straight off the shelf from a specialized OEE data modeling and reporting company, lots of them out there, and it picks up all kinds of signals from the line. So if we want that OEE dashboard, what we need to know is all kinds of uptime, downtime things. So we generally get that from the line. Uptimes, error codes, things like that. We plug tags into sensors on the line and get that data into a historian, or Aveva has quite a big system on that, but we get it into some type of system where we can then read those basically up and downs of all kinds of sensors and codes coming into the programming of the machine. Now, what we don't often do is really get the I/O signals, but more often it's already something that is translated by the PLC on the machine. But anyway, it gets into, we get data from the machine, and this data is really not telling us yet, I've had a 15-minute breakdown. Maybe I was down 15 minutes because of this and this, but it's not going to translate it into percentages at all. So for that, we need some additional input. Now that input, and that's why I said the operator will see more than that, the operator usually also has their own input thingy. They will enter things like the reason code, or they will correct or maybe just confirm those errors. And that will all go into a data model, right? And when we just put a piece of OEE software in place, what we get is a nice data model that is pre-populated with ways to calculate OEE. So you get your minutes that your machine is running, your minutes that your machine was down for error code 365, your minutes that your machine was down for error code 247, all kinds of input like that, and you need to connect it into meaning. So you build this data model that says, well, I've got a production run, that's so many minutes, I've got a nameplate capacity of the line, so anytime that we're just making products and we got the product counter divided by so many products per minute to get how many effective minutes was it doing, and then we can calculate percentages and make a nice dashboard out of it. The thing is, this works perfectly, and it's often a relatively cheap system to implement, to build like that. But this already requires a number of inputs, right? So you need to know what product was I making, because then you get the nameplate capacity. You need to know the up and down time, you need to know error codes, some of them will come from a manual system. You need to know when the line wasn't even planned to be working in the first place, so maybe the operator is putting it in, maybe it comes from your planning software or some smart tag on the line. So you are combining already a number of data sources into this data model. But now, let's say that I would also like to do some analysis on breakdown frequencies, right? That, because it is OEE, sort of, it will take that same data model, require different ways of presenting it. It will probably require also some specifics in the data model, since this is a very standard question that when you have an OEE dashboard, you also would like to be able to analyze, how did my cleaning times evolve? How did my breakdowns evolve? Do I have repeating breakdowns? Breaking down things, not on the line, but in the categories of OEE wastes. That is a common question. So it's usually built into that same system, but you already see we are building a new dashboard on top of that same data model. Now, what you can also imagine is that you want to extend it. Let's say we also want to have the material, the quality part, the material waste part. So we're going to add in some things like how much waste did we make? And by having the waste in here, we can go to what is the quality percentage. But for such a quality dashboard, they can work with, we made so much waste that is product group A, and we have produced, we take this from Oracle or SAP or something like that, we've produced so much good product of the same product group. Combine them, you get a waste percentage. It would be much more interesting if you can combine that with your OEE data, because that OEE data will have all kinds of things like how often did that line stop? Maybe even, were we producing waste around setups? Or are we producing waste at certain products within this product group? All kinds of things like that. You can find very nice things in that data. And here comes the trick. So why I think data lakes and sharing your data models, but as sort of part of the data lake, is so important for good continuous improvement within your organization. This translation is very different from that translation. So you will have people in your organization who are quite adept at getting those machine tags into a historian or into a nice data lake or into any data system where it can then be accessed. This often requires a sort of a pre-model where timeline series, so time-based data, which is very often what comes off a line, so from 0 hours until 30 minutes, this I/O signal was up, and then it was down for 30 seconds, and it was up. That information, what tag was up or down, has to be translated into what does it actually mean? Because most people in the organization do not want to make this translation, but also cannot. But many people in the organization will understand it if your first model puts into your data lake from 0 hours until 30 minutes, there was good production time. And during that time, we made 100 products. And then there was 30 seconds of short downtime due to the packing station. That is brilliant data to have. That is something many other people can use. Now, not everyone who can use that type of data, understand that type of data, can also build dashboards. But many people in your organization can learn that skill and want to learn that skill. So very often what I see is that we've got a couple of brilliant colleagues within various departments, right? A lot of them in engineering, although it is usually actually the engineering, then the OT part, the operational technology, the people programming the PLCs and really working with the lines. They are in that set. They can definitely upskill to also build your dashboards, but they are rare and overburdened generally, especially those that can do the whole line. But in your technology department, your quality department, your finance department, your CI, what I often see are people who aren't that good, that trained at getting data from the raw systems, definitely not into nice data models. But if you give them the data, they will make your links. They will use it because they understand the processes. And that is the big difference. The big thing you want to unlock in your organization is that those people who do understand how the processes are linked, and that if you know, for instance, the waste that is produced with a batch, and you can link that to the uptime and downtime, and you can link that to a cleaning temperature, then you can get a very nice cause and effect model. Those people, they need that data, right? Give them the data. Make sure that you get it out of the lines and into a data bus, a data lake, whatever you want to call it. But also every time that you make a nice data model out of that, because remember that OEE dashboard, it lives on a data model. It lives on a model that takes those inputs and says, okay, I've got my 24 hours, so much was planned production time, so much was good production. I measure that from the good product coming in. I have an additional sensor down the line somewhere where the ready pallets are entered into my accounting system. I can calculate some quality percentage from that. I've got my sensors on the line telling me which type of downtime. So all those things, that is a data model. Now, sometimes you will need to go back to the source data, but very often that part of the data model is brilliant input for somebody wanting to build a dashboard, but they would like to also add in something with quality, something with waste data, something with personnel planning. All kinds of nice nuggets of information, because the data model that you use for the OEE, in it has all the shifts and which lines were running at which times during which days. That is brilliant information that you need it for the OEE calculations, but you can imagine that if somebody is looking into labor calculations, and they can have the labor system, right? So your hour registration system telling you how many temporary workers, normal operating staff were at the plant at each time, and they just need to also know which lines were running. Brilliant combination. Really not always in the HR system. Very often it's not, in fact. So if you can combine data models that somebody else built, you are making these connections and the ability to analyze your processes, and also the ability to steer your processes, by the way, a lot more accessible. So in your organization, go for opening up that data to those people who understand the different processes, but might not be too versatile and skilled in getting the raw data. They can learn to dashboard. They can learn to put those analyses in. What I see quite often is that some central IT department will make all of these dashboards. And there is mostly two reasons. One is they have the skills, so we've got a couple of data analysts. It's their job, they will do it, and let's not teach data analytics or dashboarding skills to people in the quality department, which I think is a very short-sighted way to do it. Now, I'm not saying that everyone in your quality department should be able to make dashboards, but I'm quite sure you've got one or two people in there who would like to learn. So give them the opportunity, upskill those people, because this is just the next office, right? The next MS Office. Nowadays, everyone knows it, although I've been to factories and supplier companies where somebody was there with the function title of computer operator, because the real technologist, they knew the process, but they didn't know how to get it in and out of a computer. So they had another person there doing it. We may laugh at that, but that is exactly what we are doing right now by having specific data analysts build all of our dashboards. We need to get these skills into our process knowledgeable workforce. And then the second one is security reasons, because in those data lakes, of course, is a whole lot of information, and it's already organized in a very nice way. So it's much easier to get maybe too much information. There might be processes where this is really the case, but in general, really, I mean, those people who need access to your data will do so much more good for your organization than the little bit of data leak here or there that can happen. The whole idea is that you split it down, so you make a one-way street from your entry into your data lake, that means that somebody who has access here cannot change anything on your processes. I do see some older type of, one line to go from machine to some sort of dashboard that has sort of open connections and that allows, because it was built by the OT guys anyway, and they know what they're doing. So they build in open ports, very tricky. But if it is a one-way flow of data anyway, there is no physical security problem. So people are not going to change how the machine runs based on what visualizations they make in Power BI or Tableau or something. The only thing is the data comes out. Okay, well, that is a bit of a trust issue within your organization. Now, I know some of you watching might be in defense or very high technological industries where the real secrets of how the process runs is really a big thing. But for most companies, my advice is, don't be so strict on that part of your security. Because how to make a bread or how to roll a piece of steel, that information is already out there. You've got your consultants everywhere, you've got your supplier companies everywhere that look at different companies. That info is on the street. It is making sure that you in your company can manage that process optimally. And for that you will do so much more good by making it available for the people who know the process. That is the power of data lakes in CI. And all of those data models, they should also be available, right? So the nice thing is, and I really challenge you to open up your Power BI, your Tableau, your other BI type of software. You can add in multiple data sources and again create your own data model. That is also what those programs will do. They have two functions within that one program. But as part of your input, you can take the direct waste reporting. You can also take somebody else's data model fully into it and then recombine it a bit for your purposes. It'll be much faster and a very nice way to quickly get to the correct dashboarding. If you want to have good dashboarding but also quick reaction and a real kaizen way of doing continuous improvement, open them up to the people that want to improve your processes so that you get the information in the way that people like. It'll be faster than your central department, but much more importantly, you will involve the people who really know the processes. They'll be much more motivated. They will build the stuff they need and get the optimizations going in their factories. So I hope I sort of triggered you, motivated you to go and fight for this, because unfortunately in many companies that is sort of needed. Fight for getting those data lakes and getting access to each other's data models, sharing that information about your processes with everyone who really wants to improve over there. Now, if this triggered you to go and do something about it, don't forget to also hit that like button and suggest some other topics. This actually came from a viewer question as well about make some more discussions on how to use big data. And I'm not too sure yet about AI, but the newer things we do in CI, so new developments in technology, but also to think about how to put that into your CI. What does it mean for us in the improving business? And that is one of those answers to that question. And there will be more. There will definitely be more, because this is a broad topic. But okay, for now, I wish you the best of luck getting those data lakes set up and used within your organization. And as always, don't forget to also enjoy the continuous improvement journey.